Okay, let's keep talking about arithmetic sequences, and our idea is going to be trying to find a general formula, just as we were doing in the last example, but here the information they'll be giving us, it will be slightly different. So let's take a look. This is example 23.12. Find the general formula of an arithmetic sequence that satisfies this given property. So in part A, they've given us the D, the common difference, that's 12. That means every time you move up the sequence, you add 12. And then they've also given us, interestingly and slightly irritatingly, not the first term. They've given us the sixth term. A6 is equal to 68. And we want to come up with a formula for AN. And the general fact that we have about arithmetic sequences is that they look like this. AN is equal to A1 plus D times n minus 1. That's just given to us. That's like the formula for arithmetic sequences in general. Keep that in your head. And we don't know A1. That seems to be the thing that's missing. And so what are we going to do? We're going to use the fact that they give us one member of this sequence. A6 is equal to 68. So in this formula, if we put 6 in for n, and put it in right there, then this should all equal 68. Let's go ahead and do it. So we replace 68 with AN. We keep the A1 in there. That's the part we don't know. The common difference we know is 12. And then n minus 1, the n, if we're talking about A6 here, n is 6. So this is 6 minus 1. Now, this we can solve, and that will give us our A1 back, and that should allow us to finish the rest of this. So this is 68 is equal to A1 plus 12 times 5. 12 times 5 is 60, so this is 68 is equal to A1 plus 60. And if we subtract that 60 from both sides, we get that our A1 is equal to 8. Now, we have D already. That was up above. D is 12, and A1 is equal to 8. And so with those two, we can go ahead and put together our formula just by substituting them in here. Our general formula for AN will be A1, that's 8, plus the common difference D, which is 12, times n minus 1. And as usual, we can simplify this thing a little bit. AN is equal to 8 plus 12n minus 12, and then combine the similar parts there. This is 8 minus 12 is negative 4 plus 12n. And you'll find, if you want to plug in and try finding A1, A2, A3, A4, A5, A6, that for A6 you will get 68. All right, that's it for part A. Go ahead and try parts B and C on your own. Come back and see what you can do. Or we'll do them together. Here we go. Part B. Here, A1 is negative 5, and A9 is 27. We are going to use the same strategy as before. Notice that what's missing, they've given us the first term, and they've given us one of the later terms, 27. But what they have not told us is what is the common difference D. Now, whatever that common difference is, D, if we start with our first term, negative 5, and we add D to get A2 and add D to get A3, when we get all the way up to A9, we should end up at 27 as our answer. You might be able to sort of think that through and come up with D, but we're just going to do it algebraically by using our formula. So the formula in general is AN is equal to A1 plus D times n minus 1. Now, we know A1 already, it's negative 5, and so we're just going to substitute in A9, 9 for n. A9 on the left-hand side, that's 27, because we're told that A9 is 27. And what is that equal to? It's equal to, A1 we also know is negative 5 plus D times, and since this is A9, n is 9, this is 9 minus 1. So we have 27 is negative 5 plus 8D. And let's see, if we add 5 on both sides, we're going to get 32 is equal to 8D. And then dividing by 8, we get that D is equal to 4. We found D, and we knew already our A1. And from those two, we should be able to plug into our formula here. and get a general form for an. An is equal to a1, that's negative 5, plus 4 times n minus 1. And if we simplify that by distributing, we're going to get minus 5 plus 4n minus 4. And then adding things together, we're going to get minus 9 plus 4n. I did skip a step there. If you're wondering where this stuff in the box came from, go ahead and simplify the previous step, and hopefully it will work out correctly. Okay. That's the general form of the nth term of our sequence. Let's go ahead and look at part C. Part C is interesting because here what we've been given is A5, the fifth term of the sequence, which is 38, and A16, the 16th term of the sequence, which is 115. We have not, frustratingly, been given either A1, the first term of the sequence, or the D, the common difference. We're going to need to find both of these. So find A1 and D. And once we have A1 and D, we can get our general formula for AN is just equal to A1 plus D times n minus 1. Okay. How do we do it? Well, we're just going to use these two data points and substitute each one of them into this equation. For the first one, we're letting n equal 5. When n is 5, we have that A5, the left-hand side, is 38. And on the right, we have A1 plus D, we don't know, times 5 minus 1. And at the same, so this is substituting in A5 equal 38. At the same time, and sort of simultaneously, I'm also going to substitute in A16 equal 115. When we substitute that in, the n is 16. The left-hand side, AN, is equal to 115. And what is that equal to? It's A1 plus D times our n minus 1, which is 16 minus 1. So the idea is, since we were given these two values of AN, A5 and A16, I substitute each one of them into our general formula here, and that gets me this one and this one. We now have two equations, 1, 2, and if you look at the variables in these equations, this one has the variables or the unknowns A1 and D. This one has the variables A1 and D. We have two equations and two unknowns. We should be able to solve them using something about combining equations. There's a bunch of different techniques for doing this. We'll use one of them here, and this is something that you might want to do a little separate review of if it seems really unfamiliar, but we'll take you through this example. All right, so what I'm going to start by doing is just simplifying both of these equations. So the first one, 38, is equal to A1 plus 5D minus D. I'm sorry. Let's undo that. I can subtract 5 minus 1. So this is just A1 plus 4D. There we go. On the right-hand side, I have 115 is equal to A1 plus 15D. And what I notice is that both of these have just a plain A1 in them. Now, there's a bunch of different ways to solve. This is a system of two equations and two unknowns. And there's a bunch of different methods for solving these. There's the elimination method, substitution method, and so on. I'm going to use the substitution method, which involves taking one of the equations, getting a variable by itself, getting A1 by itself. How do I do that? I subtract 4D from both sides. So we get 38 minus 4D is equal to A1. Now we have an expression for A1. A1 is 38 minus 4D. I am just going to substitute this into the other equation. So put this guy into that equation, substitute for A1. So I'm just going to copy this equation on the right here, 115 is equal to, and then A1 is 38 minus 4D. And then we have the rest of this equation plus 15D. That's a 4D. Okay. Dropping my parentheses, 115 is equal to 38 minus 4D plus 15D. And minus 4D plus 15D is plus 11D. So this is 115 is equal to 38 plus 11D. Getting the D by itself, I'm going to subtract 38 from both sides. And then I'll end up dividing by 11. Those are my upcoming steps. Let me see. On the right-hand side here, I have 11D. On the left-hand side, 115 minus 38. I think that's a 77 over there. And I notice that now if I divide by 11, it goes in evenly, which is nice, suggests that whoever designed this problem was being kind, I guess. D is equal to 7. So we've now found our common difference, D, and all we need to do in order to get the general formula for this recurrence relation is find A1, the first term of the sequence. If this is our D, we could just substitute this back into basically any equation that has D and A1, and I'm going to put it in here, substituting it for D there, and then that will give me my A1. Go ahead and do it on your own, then come back and check with me. Let's see how it looks. Okay, so sub 38 minus 4 times 7 equals A1. So this is 38 minus 28 equals A1. And this says that A1 is equal to 10. Now, we can put A1 and D together to get our general formula for the nth term. The nth term of this is given by AN is equal to A1, which is 10, plus D, which is 7, times n minus 1. And you can keep it like that, or you can simplify AN is equal to 10 plus 7n minus 7. And the 10 minus the 7 gets us AN is equal to 3 plus 7n. All right, this is our answer. That's our general formula for the arithmetic sequence described in part C. That's it for now. In our next video, we're going to look at what happens when we start to add these things up.